We're 7b, we're talking about discrete probability distributions, and all of these dot points and things that are written here are important, so we will read through them, we will talk about them, and then we'll address the examples. So we said in the previous exercise two types of variables, continuous and discrete. We're familiar with that distinction, and now we're looking specifically at discrete variables, and all of this test on chapter 7 will be about discrete variables. And then in term 3, when you do your test on the other part of statistics, so chapter 8 and 9, which is also in this booklet, that'll be on continuous variables. Okay, so we're looking specifically, explicitly at discrete. So for any discrete random variable, there is a corresponding probability distribution. Okay, that will become clear in a moment, which describes the probability of a particular event occurring. So if x is a random variable with outcomes x1, x2, all the way up to xn, okay, so we use capital X to denote the random variable that we're talking about, and we use lowercase x to denote the specific events that can occur. All probabilities occur between 0 and 1. That's the first dot point. Okay, no probability can be larger than 1 or less than 0. All events lie between 0 and 1. And the sum of all probable events is equal to 1. Okay, so when you add up all the events that can occur, the probability of them, you will always add to 1. And then in brackets there we've got, if you list the probabilities of the distribution in order, that describes the probability of it. So we're going to be seeing this notation a bit. Probability of capital X equals lowercase x. And what this means is it's the probability of this event occurring, the probability of the random variable taking on this event. Okay, so we've said lowercase x is the event, all right, and big X is the random variable. That's the experiment we're performing. So in this one, I haven't made an example of, I've just said this probability distribution. So one way you might think about this is it's a spinner, okay, and they're not all equal, okay, but they've got, one of them's got a 0.2 chance of occurring, so that's 1. 2 has a K of occurring, so we'll figure that out in a moment. So I'm just dividing that up. This is event 2, event 3, event 4. And so the probability of event 1 occurring is 0.2. The probability of event 3 occurring is 0.24. The probability of event 4 occurring is 0.22. So this is a good way to think about it. So with this spinner, you know, not all of them are equal, but each event has a specific probability of occurring. And so when we use this terminology, I understand I'm jumping ahead a bit, when we use this terminology, the probability, what's the random variable? What's the experiment we're performing? Here we've got a spinner and we're spinning it, okay? So X, capital X, is spinning the spinner. That's our experiment. Spinning spinner. So this means that when we spin the spinner, okay, when we spin the spinner, what is the probability of it occurring at event 1? What is the probability of it occurring at event 2? These are the events. This is the experiment, this is the events. So what's the probability of the experiment taking on this event? When we roll a dice, what's the probability of it popping up with a 1 or a 2? Okay, so where were we up to? So then I've got like a bit of a demonstration here as well. Okay, so a fair coin is flipped twice. The random variable X is the number of heads, because you could assess anything there, couldn't you? The random variable could be the number of tails, could be the number of heads, could be the number of times it lands on its side. Okay, it might be 0. Suppose the possible outcomes are 0, 1, or 2. So they're the possible events, aren't they? You can either get 0 heads, you could get 1 head, or you can get 2 heads if you're flipping a coin twice. And then I've listed the corresponding probabilities. We can display that as a table. That's what we've done there. That's called a probability distribution table, or as a graph. Okay, if you were to put that table into a graph, that's what it's going to look like. Okay, then we have a special case, which is a uniform discrete probability distribution, and that's where each event has an equal probability of occurring. So, in the case of a dice, okay, if we were to draw the distribution for a dice, these are the events, and then the probability, when we roll the dice, that a 1 will occur is 1 on 6. A 2 will occur, 1 on 6. Okay, we would anticipate, if it's a fair dice, that the probability of every event is equal. Okay, and so this is a special case called a uniform, what's it called? Uniform discrete. Uniform because each probability is uniform. It's the same throughout each event. And so just that terminology again, it's a little bit hard to wrap your head around. What is the probability that when we perform this experiment, this event occurs? These are the events. 1, 2, 3, 4, 5, 6. They're the possible outcomes you could have. Okay, then we've got what the mode is. The mode is the event with the highest probability, and the median is the event that corresponds to the cumulative sum of the probability reaching 0.5. Okay, that sounds complex when I say it like that, but let's get into the example. So we have this distribution here, and I haven't given a context to it, but I think a spinner works well. You know, these are the events that can occur. We're going to spin a spinner, 1, 2, 3, or 4. They're not equal, like they're sort of different areas, so there's more chance of it landing on some. The first thing it says is find the value of k. Well, firstly we know all probabilities add to 1, so it has to be one of these events. And so that means 0.2 plus k plus 0.22 and plus 0.24 equals 1. When we add all that together, we're going to get 1. So let's do this. We're going to have 0.44, 0.68, and so k is 1 take 0.68.
It'd be 66, wouldn't it?
Yes, thank you. And so we've got 0.34. Thank you. So we've found this value of k. That's what it says to do first. Okay, and some of them will chart like that. They'll just say, you know, probability distribution, all events have to add to 1. The probability of all events has to add to 1. So what is this value of k? 0.34. That's part A. Okay, part B. Is this a uniform distribution? No. Okay, uniform distribution has each event has the same probability. So for part B, we're going to say no, as each event has a different probability of occurring. Okay, part B. Find the probability of x being greater than or equal to event 2. So that means you have to spin the spinner and get a 2, 3, or 4. So there's two ways we can do this. You can say, oh well, it's the probability of 2 plus 3 plus 4. Or you can say it's the probability of 1 take away that. Okay, if we take away this probability, it's going to leave us with the probability of this event. Okay? If you're not sure how to do that, you're just adding them up. So probability of x being greater than 2 is 0.34 plus 0.24 plus 0.22, which is 0.8. That's the simplest way to think about it. It has to be 2 or 3 or 4. What's the probability of that event occurring? Okay, find the mode of the distribution. So the mode means the event with the highest probability. So we just look at it and we go, which number is the highest? 2. Okay, so the mode then is not the probability, it's the event. The mode is x equals 2. Okay, and what that means is the mode is the random variable takes on the event 2. Okay. E, the median. Okay, so this one's a little bit trickier, requires a little bit more involvement. We've said the median occurs when the cumulative probability reaches 0.5. So if we look here we've got 0.2. Okay, so it's not at the median yet. And if we go 0.2 plus 0.34, we've got 0.54. Okay, so we've reached enough probability for the median. What event did that occur at, doing the cumulative probability? It occurred at event 2. Okay, so our median is 2. We will do a few more examples of these if you're not sure how we got that far. It's when we just keep going until we get to or exceed 0.5. Excellent. So let's move on to example 2. So this is a discrete probability table Now I've got a discrete probability function. Okay, part 1 says find the value of k. So what this means, okay, we've got this function and it's valid for x is 1, 2 and 3. So that means the possible events are, let's draw up a table for it, x and x, okay. If x is 1, excuse me, probability of x is 4, x is x. When x is 1, what is p of x going to be? It's going to be k on 4. When x is 2, p of 2 is going to be 2k on 4. And when x is 3, p of 3 will be 3k on 4. Okay, so these are our possible events, 1, 2, or 3. All right, they're the possible events. We can take this value, it can take this value, or it can take this value. Here's the probabilities, but we've still got this k, so it's not really clear. But we do know that all probable events add to 1. So that means k on 4 plus 2k on 4 plus 3k on 4 equals 1. Okay, if these are the only 3 events, all of the probabilities have to add to 1. And so we'll get 6k on 4 is 1. Multiply both sides by 4. We'll get 6k is 4. And then divide both sides by 6 to get k is 4 on 6, or in simplest terms, 2 on 3. So if k is 2 on 3, all right, then what we're going to have here, the probability is going to be 2 on 3 on 4 on 1. We can do our AD and BC. We're going to have 2 on 12 or 1 on 6. Okay, now we've said again, k is 2 on 3. That's what we've found here. So we've got 2k on 4. That's going to be 2 times 2 on 3 on 4 on 1. So that's going to be 4 on 3 on 4 on 1, which is 4 on 12, or 2 on 6, or 1 on 3. Okay. Now I might just make a link here. So we've said 1 on 6 could be 2 on 12. And we've seen 1 on 3 could be 4 on 12. All right, and we can calculate the last one. Or we can go, well, all of these have to add to 1. So they add to 6 on 12, so this one has to be 6 on 12. And we can do it from here as well. So k is 2 on 3. So this is going to be 3 on 4 times... yeah, 3 on 4 times 2 on 3, which is 3k on 4. So it's 3 times 2 on 3 on 4. So that's going to be 2 on 4, or half. And of course 6 on 12 is half, so we can see the link there. All right, so a little bit, look, I don't want to get us confused with these fraction operations that we're doing, okay? We've found the value of k. You can just chuck that in your calculator now to find what is 2 on 3 on 4, that's going to go there. What is 2 times 2 on 3 on 4, that's going to go there. What is 3 times 2 on 3 on 4, that's going to go there. All right, but I've done it manually here, but we can rely on our calculator if we're a bit worried about that. Any questions about that? Okay, draw the probability distribution. So we've drawn here a table for it. Okay, that's sufficient. If it's specifically, say, table or graph, if we were to draw a graph of this, okay, we're going to have the probability on the y-axis always, and the possible events on the x-axis. The possible events are x is 1, x is 2, or x is 3, and then it's just a column graph. This can be 0.5, 0.25, and I'll just approximate it. We've got 1 on 6, which is what, 16. We've got 4 on 12, which is a third, and then we've got 0.5. Okay. And so you can see from both the graph and the table, like what's the most probable event of occurring? Well, here this has got a 50% chance of occurring. And here, you know, it's extremely big. This is the biggest one, so this is more likely to occur. Excellent. Find the median and the mode. Okay, let's do mode first because that's the easiest one. Mode is the event with the highest probability. 3 has a probability of 0.5. The median, however, the median occurs when the cumulative, that means when we're adding it together in order, the cumulative probability reaches or exceeds 0.5. So if we look here we're going to have 2 on 12 plus 4 on 12. That's going to give me 6 on 12, which is 0.5. So it reaches 0.5 during this event, event 2. So the median is actually x equals 2. Okay, so that's it. That's what we're working through today, exercise 7b. I think we're going to find the content of this chapter a fair bit easier than the last, hopefully. Cool, thank you.